8.12. You can read the question first. Okay, there is one uniform horizontal beam AB. So beam AB here is your rigid body. Length of the beam is 110 centimeter and it is at rest on the balcony railing. The red color here is balcony railing. Okay, so at the edge of the beam, we hang with a flower basket that have a weight of 23 Newton. Okay, so the basket is counterbalanced by a body. There is one body here at the edge of the beam at point B. The weight of the body is W1. The beam is, by the way, at rest on the balcony railing. So there is one force here that acted at point O. The mass of the beam is 3 kilogram. Okay, the body here, the beam AB has its own weight. So the weight of the beam is 3 kilogram. The question asks to calculate the weight of W1 needed and also the force exerted on the beam at point O. Okay, let's see the solution. The first step is to draw free body diagram. Then let point O as the rotation axis. Okay, we draw the free body diagram. We have beam AB here and point O, which is attached to a balcony railing. Okay, point O here will be the rotation point. Okay, so here is a distance from point A to point O and point B to point O. It is given in the question. Okay, so center of gravity of beam must be at the middle of the beam. Okay, it has mentioned that the beam has a mass of 3 kilograms. So the beam itself has weight. Okay, so distance from point A to center of gravity, which is at the middle, is 0.55 because beam AB has 1.1 meter long. Okay, we have weight 1 that attached at point B. The question asks for the weight 1. Direction of weight 1 is downward, so force of weight 1 in Y component is negative. Okay, torque. Okay, so torque is F cross D, right? So force is W1 and the distance from axis of rotation is 0.75. Okay, remember our point O is the rotation point. So distance of the force to point of rotation is 0.75. It has been perpendicular, right? Okay, so next is for direction. Okay, try holding a pen or pencil horizontally like this figure. Hold the pen at this point and try to pull the pen at the end of the pen downward. Okay, where is the direction of the pen move? It will move clockwise, right? Okay, because the direction is clockwise, thus our torque is in negative. Now is force, the second force, which is weight 2. Here is your flower. The question has given the weight of the flower, which is 23 Newton. Because direction of force of weight is downward, thus weight is negative 23. Okay, for the torque is F cross D. Our force is weight, which is 23. The distance from axis of rotation is 0.35. Okay, it has been perpendicular. No need to resolve. Okay, so next, direction of torque. Okay, you can hold your pen and pulling it downward at point A. So you can see that your pen will rotate anti-clockwise. Anti-clockwise is a positive torque. Next is wake of the beam itself, okay? Because the beam AB has a mass, it's a rigid body, right? So it has a mass, thus this beam will have its own weight, okay? So its weight is acted on the center of gravity at the middle of the beam, okay? So force number 3 is weight of the beam itself, which is mg. Okay, it is still downward in direction. That's why we locate negative here. Okay, the mass of the beam is 3 kilogram times gravity. You will get negative 29.4 Newton. For torque, okay, so torque is F cross D. We have the force 29.4 and distance of the force to the axis of rotation is 0.2. Okay, because 0.55 minus 0.35, you will get 0.2 meter. Okay, so force 29.4 times 0.2, it has been perpendicular, so we don't need to resolve the force. Next is direction. Okay, so direction of this torque is clockwise, so it will be negative. So you will get negative 5.88. The fourth force is a normal reaction force at point O because the beam is at rest on the balcony railing. That is something that holding the beam. Okay, this is just like a pivot point. Okay, so normal reaction force is a positive because the direction of force is upward. Okay, for torque of normal reaction force, it will be 0 because it is exactly on point O. Since the beam remains at rest, so it doesn't move, thus the system in equilibrium. Okay, there are two conditions for the equilibrium system. Okay, the first one is the vector sum of all torques of the system is 0. So you can add all the torque that acted. There are 4 torques, right? That acted on the system. So we add on all the torques equals 0. Thus, you will obtain value of